Hello everyone, today we're gonna keep going with chapter 4, matrices, and then today we're gonna relate some networks as well. So it's called introduction with the transition matrix. Okay, so suppose we have a certain toys and we have two choices activities each Saturday night, either going to the movies or stay at home. So M representing movie, S means home. And then we're gonna establish like 20% of people who are going to movies this Saturday will go again next Saturday. And hence 80% who going to movie this Saturday will stay at home next Saturday. So this one give us the like information which is like 20% people who are going to movies Saturday and go again next Saturday. 80% who going to the movie Saturday this Saturday, next Saturday gonna stay at home. And 40% people who stay at home this Saturday will going to the movie next Saturday. And 6% people who stay at home this Saturday will gonna be stay at home again next Saturday. So the networks looks like this. Movie as 20% of people going to movie next Saturday, going to the next Saturday again, so which is 20%. And 80% who going to movie and next Saturday will stay at home. And 40% of people going to the movie next Saturday, but this Saturday gonna stay at home. And the 60% of people gonna stay at home. So I create this matrix that looks like, okay, 0.2 equal to 20%. So if you're going to movie this Saturday, 20% of people are going to the next Saturday again. And 80% people are gonna stay at home. 40% people who gonna be stay at home and gonna be going to the movie next Saturday, and 60% are gonna stay at home. So we can say this matrix is called the example of translation of the matrix. And if you go into the column, you can say they always equal to 1. 0.4 plus 0.6 equal to 1, 0.2 plus 0.8 equal to 1. So always equal to 100%. And okay, property of this transition matrix. So a transition matrix is always a square matrix. Okay, so 2 by 2, 3 by 3. Okay, the important feature, which is the transition matrix, is each column total equal to 1, which is 100% if you're adding all together. Okay, let's start with the first example. Okay, so we had a park has two rides of preschool children. There are Ferris wheel, which is F, and merry-go-round, which is M. So after each ride, children can choose which ride they want to do go next. There's a park. Observe the following. So 70% children on the Ferris wheel will and go to the Ferris wheel again. So 70% are going to again, and which means 30% of people who actually will go to the merry-go-round next time. Will go next time. Okay, and 40% children go on the merry-go-round will go merry-go-round again, which is 60% going to Ferris wheel next time. Does that make sense? Yep. So first one, find the percentage of children going to Ferris wheel who will going to merry-go-round next time. So which is in question A. So A will be 30%. And B, find the percentage of children going to merry-go-round will go to the Ferris wheel next time will be 60%. Perfect. And now we're gonna make a matrix. So Say, let's try with this right and next right. Perfect. Okay, so we start with F and merry-go-round, F and merry-go-round. So let's try. 70% will be going to the Ferris wheels and going to the Ferris wheels again, so which is 0.7. And 30% will go next time, which is 0.3. And these 40% people going to merry-go-round and go merry-go-round again, so this is 0.4. And this is will be 0.6. Hopefully that makes sense for you guys. All right, so we're gonna go with the applying a transaction matrix. This is a same example with a weekly pattern of the behavior again. And for example, if we have 200 students, 200 people going to the movie this week, and let's say how we go. So 20% of it, or 40 of these people will go to movie next week because it's 20% of 200. That's a 40 people. So that's why we calculate for the next time, and which means 80% these people stay at home, which is 160 people gonna stay at home. And if there's 150 people stay at home this week and transaction matrix, so if you stay at home this week is 150, so 40 of this, which is times 0.4 is 60 people will go to the movie and next week, so 60 people, and 90 people will stay at home. So if you're adding all together, that's 150. So we can say that 200 people went to the movie this week, 150 stay at home. Then the number of people going to movie next week will be 0.2 because it's a 20% people will go again of the 200 people, and plus the 40% of the 150 will go again, which is go to the movie, and adding all together because there's a two different surveys. I mean, different kind of groups, the people, and then that's why if you go here and other people have to go other way, so that's how that works. And the number of people who stay at home next week, okay, so it's 80% people gonna stay at home for the which is 160, and 60% people of the 150 will be 250. So that's how that works as stay at home. Okay, now let's try with this question. So we had a transition diagram already, and there's the diagram, and that's the matrix we can know. First question, let's have a look. So you have what's the percentage of children on the Ferris wheels and going on the Ferris wheels next time? That's question A. So we can say in the matrix is 0.8, 80%. And for question 2, that will be go to the run next time is 20%. Perfect. And question B, if there's a 140 children went on the Ferris wheels, how many they could go next on? So if there's 140 Ferris wheels and they're going to Ferris wheels next time again, so that will be 140 multiplied by 80% equal to 140 times 0.8. That's around like 122 people. So there's 122 children going to the Ferris wheels next time again. And 20%, so we have for 20% is 140 times 20%, that's equal to 28 children going to the merry-go-round next time. All right, and question C. And this time we go with, if there's 140 children went to the Ferris wheels and 80 children went to the merry-go-round, how many children will go on the Ferris wheels next time? So there's, first thing first, let's try with 140 multiplied by 80% again. So this is 112 going next time for the Ferris wheels if you had 140 children going to Ferris wheels. And 80 students going merry-go-round this time and merry-go-round this time. So, and the 70% they go into the merry-go-round again, but actually only 30% going to Ferris wheels, so which is times 0.3, that equal to 24. And you adding those two numbers together will be the proceed. You can say 136 students will go on the Ferris wheels next time. Perfect. Hopefully that makes sense. And yeah, that's all for the applications and transaction matrix. Please let me know if you have any questions. And I'll see you guys next time.